So I guess you just finished up the Chapter 3 test, and then we'll start Chapter 4. You're absolutely going to need some sort of graphing calculator for Chapter 4. There are some things that we're going to do that we're flat out not going to do it all by hand, and that by hand would be rather unpleasant. So you're absolutely going to need a TI-83 or a TI-84 calculator. If you have some other graphing calculator, then my videos aren't going to help you learn how to use it. But if you're comfortable with your calculator and you can figure out the things, then that's great. If you can't, if you have a calculator that's not one that I use and you have the instruction manual, you probably could come by my office and we can sit down and try to figure out your calculator together. But I'm not able to do everything on every calculator, so having a TI-83 or 84 would definitely make this chapter much easier than if you don't. So the section 4.1 is a section on lines. The first 10 problems in section 4.1 give me equations written in function form that represent a line. So this is, this statement f of x equals 2x minus 10 is equivalent to y equal 2x minus 10. The function notation f of x is acting as the y in this particular instance. So because this is essentially an equation solved for y, when I go to answer the first part as to what the slope is, if an equation is written in function form or solved for y, and it's in the form y equals mx plus b, the number in front of the x is the slope. So for this particular problem, the slope is the number in front of the x, which is 10. Because the equation is in the y equals mx plus b form, or f of x equals mx plus b form, the number after the x is the non-zero part of the y-intercept. And for me, I'm going to write the y-intercept as the point 0, negative 10. So those two parts of this I'm able to do without any algebra. The next part, I'm going to be stuck using some algebra. To find the x-intercept in part C, I take the function itself and set it equal to 0. So I'm going to go 2x minus 10 equal to 0. And because there's not a square, I'm not going to factor. I'm just going to add 10 and divide by 2. And I'm going to get x equal to 5. And when I write my intercept, the x-intercept, I'm going to write it as a point. So I'm writing my answers up here. I'm writing the point 50 as my answer. So I'm done with part C. Now I'm ready to do part D, which is sketch a graph. And there's lots of ways to sketch a graph properly. One way is just to plot the intercepts and connect them with a line. The other way would be to plot the y-intercept and then use the slope, which is 2 over 1, and go up 2, right 1. So you can plot, there's probably the two common ways to do this. You can plot negative 10 on the y-axis, and because the slope can be written as a fraction, 2 over 1, you can go up 2, right 1. You can do that a couple times and generate more points and then connect those points. The alternate way to do it is just to plot the intercepts and connect them. Graph doesn't need to be that accurate, and so I'm going to make a very inaccurate graph, and I'm going to do this second strategy. So I'm going to plot the x-intercept, which is at 5 on the x-axis. Notice I didn't even label any numbers on my x-axis. I just made 5 ticks. Similarly, on my y-axis, I just made 10 ticks, and I understand that that represents the point 0, negative 10. And now I'm going to connect those 2 points with a line. The line should go on forever, and eventually I'm going to stop drawing. It's appropriate, but I don't always do it, to put arrows at the end of the line to mean that the graph doesn't end, that it goes on forever. So for sketch a graph, I'll write here, see below. In the last chapter, we determined intervals were functions, our graphs of functions were increasing or decreasing. And lines aren't going to be like increasing in one spot and decreasing in another. Lines are going to be just always doing the same thing. And this line, as I move from left to right, it has positive slope, so it's going up. I would say that this line, the graph of this line is always increasing. So my answer for part E, determine whether the function is always increasing, always decreasing, or constant. Because as I move from left to right, it's always getting higher. I can say that this graph, or the graph of this function, is always increasing. It's everything that there is to do for number 2 in this section. So this was, just in case it wasn't clear, it was number 2. On the next page, I'll probably have number 4. Instructions are the same. I see the function g of x equals negative 4x minus 12. Again, this is in the y equals mx plus b form, where the function g of x is serving as the y. Because it's in the y equals mx plus b form, the number in front of the x, along with its sign, but not with the x, is the slope. The number after the x is the non-zero part of the y-intercept. So for the answers for part A and part B of this, the slope is negative 4, the y-intercept is the point 0, negative 12. To get the x-intercept for part C, I take the function itself, or the right-hand side of the function, and set it equal to 0. There's no square, so I'm not going to factor. I'm going to add 12 to both sides, and then divide by negative 4. When you do that, you get negative 4x equals to 12. And then when I divide both sides by negative 4, I get x equal to negative 3. And I'm going to write that as a point. I got negative 3 for x when I replace the function with 0. And that's like putting a 0 in for y. For sketching a graph, I could plot either point and use the slope if I want to. So I could do this. Plot the point 0, negative 12. And then, because the slope is negative 4 over 1, I can go down 4 and write 1 as many times as I care to generate more points, and I can connect those points. So this is one method. One way to get a reasonable graph. Because I have the intercepts, I won't. I will just plot the intercepts and connect them. That's only giving me 2 points, and it's maybe not the best thing to do, but it's good enough. So I'm going to plot negative 3 on the x-axis. So that's the point negative 3, 0. And then somehow I need to get down to negative 12 on the y-axis, and I really didn't leave myself room, so I'm going to make really small ticks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's supposed to be the point 0, negative 12. I'm going to connect the points. Can't really go much past the 0, negative 12, even though the graph does go past that point. And sneak an arrow down there to make sure we know that it goes on. And so this is part D. That's an adequate graph. Doesn't need to be any more accurate than that. And this function, or the graph of this function, because as I'm moving from left to right, it's always getting lower, we say that this is always decreasing. So I haven't used my calculator for anything yet. I could have used my calculator to generate the graph. If I did this, y equals, I'd been doing some stuff. My plot is blacked out. I have to unblack that out. I'm going to hit enter on second stat plot. This plot one that says on, I'm going to turn off. If I don't turn it off, my graph's going to be funky. So now I'm going to graph negative 4x minus 12. And my window needs to incorporate the y-intercept. So my x going from negative 10 to 10 would be fine. But if I didn't make my y go from down lower than negative 12, I'm not going to see the y-intercept. So I'm going to make my y-min negative 15 and my y-max 10. There isn't a right and a wrong window. I just want to generate a window that was going to show -3 on the x-axis and -12 on the y-axis. -3 is in between the 10s I have for the x's, and -12 is in between the 10 and the -15. When I hit graph, I'll get a picture, and it looks, close enough to the graph that I just drew to think that my graph is completely fine. And that's all there is to do for question 4. Again, so if it wasn't obvious, I was doing question 4. Now I'm going to be doing question 6. And question 6 is tricky because to the right of the equal sign there isn't an x. So if you need to, when you're doing problem 6, because there isn't an x to the right of the equal sign, you don't have to do this, but if you want to, you can rewrite it as 0x minus 2 as opposed to just f of x equals -2, and that might help you answer the questions and find everything you need to find a little bit easier. So I'm going to live in this world, but if you didn't make this change and you're able to answer the questions without doing that change, that's great. So the first thing I want to do is write the slope. The slope is the number in front of the x. In this case, my slope is going to be 0, because 0x. This equation, 0x minus 2, it is the same as -2 because 0x is 0. And this simplifies. These simplify to each other, so they're equal. They have the same slopes. The y-intercept is the -2. And I tried to give a hint here, x-intercept if any, because there isn't going to be an x-intercept. When I go to find the x-intercept, if I take either version of these functions and set it equal to 0, this 0x, that zeroes that out. This really simplifies to the expression or the equation -2 equal to 0, because when I try to do the algebra to find the x-intercept, I get a false statement. That means there is no x-intercept. Because this is a false statement, there is no x-intercept. The graph is actually going to be parallel to the x-axis. So this is, if any, was a hint. I can graph this remarkably well without using my graphing calculator. You might need your graphing calculator to do this. So I don't have two intercepts to plot, but I could do this. I could plot the point 0, -2, which is the y-intercept, and then the slope, I can rewrite the slope in fraction form, which is 0 over 1, and that doesn't, it tells me to get from one point to another, I don't go up or down, I only go right 1. The up or down is 0. So if I did that, if I plotted the point 0, -2, and instead of going up or down, if I just went right 1, so I plot the point 0, -2, go right 1, I'd get another point, go right 1 again, I'd get another point, and the line is actually going to be a horizontal line parallel to the x-axis. This is why we say the graph doesn't have an x-intercept, because the graph doesn't cross the x-axis. So it's parallel to the x-axis. And if I used my calculator, on my calculator I'd hit my y1 button, I just type the -2 that's to the right of the equal sign, and when I do that and I hit graph, you get exactly the graph that I just gave. My window was set up for the other problem. It's maybe not the best window for this problem, but you can at least see that the graph is parallel to the x-axis and there is no x-intercept. So that's part D, so I'm going to say C below for that. And then the last thing, determine whether the function is always increasing, decreasing, or constant. I didn't do constant in the last chapter, but that's what this graph is. As I'm moving from left to right, it's not going uphill or increasing. It's not going downhill or decreasing. This graph is constant. It never goes up or go down. It's just always parallel to the x-axis. And this is an example of what it means for a graph to be not increasing, not decreasing, but to be constant. 8, I stuck a fraction in there, and there's a chance that the x-intercept's a fraction. But I don't think it is. So Again, this equation is written in the function form of y equals mx plus b. The number in front of the x is going to be the slope. The number after the x, along with its sign, is going to be the y-intercept. Those two came for free. So this is problem 8. The x-intercept, I take the function and set it equal to 0. So I'm going to go 3/4 x minus 6 equals 0. I don't much like the fraction. I'm going to get rid of the fraction on the first step of my algebra to make the work easier. So I'm multiplying through by 4. When I multiply the fraction 3/4 by 4, the 4's cancel. I'm left with 3x. When I multiply the 4 times 6, I get 24. When I multiply the 0 times 4, I get 0. And now I'm going to add 24 and divide by 3. When I add 24 to both sides, I get 3x equals to 24. And then when I divide by 3, I get x equal to 8. So for the x-intercept, I'm going to write the point 8, 0. Lots of ways to sketch a graph. Anytime I have both the x and the y-intercepts, that for me is normally the easiest way to graph. That means plotting the points and connecting them. 1, 2, 3, 4, 5, 6. So here's the point 8, 0. And then 1, 2, 3, 4, 5, 6, 0, negative 6. Again, I'm getting very lazy and not labeling my axes terribly well, but hardly matters. I'm going to connect those lines, those points with a line, put some arrows on it to signify my graph goes on forever. So that's the graph. You definitely could have plotted the point 0, negative 6, went up 3 and white 4. So if you plotted the point 0, negative 6, and went up 1, 2, 3, and then right 1, 2, 3, 4, that would have been another way to generate a second point to graph. And then I could have did it again. Went up 1, 2, 3, and right 1, 2, 3, 4, and you'd still wind up with the same graph. If you're not graphing on graph paper, then this strategy of going up and over, your graph might not be perfect if your axes aren't spaced perfectly equally apart. For part E, this graph as I'm moving from left to right is getting higher, so I say that this graph is always increasing. One more of these style of problems, probably threw another fraction in there, and I wrote the fraction in such a way that it might be cumbersome, so if you want to, you can rewrite this problem a little bit differently, but it will have the same meaning. If you wrote this as negative 1/3 x plus 12, that version of writing the problem might make it easier for you to do the algebra. I'm not sure whether it will or won't, but that is equivalent. Negative x over 3, you can move the x in front of the function to the right of the fraction and leave the negative sign and put a 1 in place of the x. This equation's solved. It's in the y equals mx plus b function form, so the number in front of the x is the slope, so this is problem 10. The y-intercept is going to be this point 0, negative 12. It's the x-intercept that's going to be the hard part if there is a hard part. I take the equation and set it equal to 0, either my nice rewrite of the equation or the equation itself. I'm going to clear the fraction. I'm going to be ultra slick, and I'm going to multiply not just by 3, I'm going to multiply by negative 3 to clear the fraction. The reason I'm multiplying by negative 3 and not just positive 3 is to get a positive in front of the x. So when I multiply the first 1/3 by negative 3, the 3's cancel. The negative sign doesn't go away. The 3 really cancels into a 1. And what I'm left with is negative 1 times negative 1. And that's going to give me 1x when I do that. The next multiplication, I'm going to get negative 3 times 12 is negative 36. And to the right of the equal sign, I get 0 times 3, which is 0. I probably didn't need to write the 1 in front of the x, and writing plus a negative looks odd, so I probably could have written minus 36. And when I go to solve this, I'm going to add 36 to both sides. and get a really large x-intercept of 36, 0. So when I go to sketch my graph in part D, so this is a computation for the x-intercept. When I go to do the part D graphing, I'm going to have a hard time making 12 or 36 tick marks to show these points properly. So when I do this, I'm going to increment by 6 on my y-axis. I'm going to go 6 and then 12. That is the point 0, 12. I'm going to increment by 6 on my x-axis. I'm going to go 6. Be nice if my tick marks were equally spaced, but it doesn't matter that they're not. We can have different scales on the axes. Still can't barely fit this. 24, 30, and that's supposed to be 36. I can't really fit it so well, but this is the point 0, 36 on my graph that's drawn really not that awesomely, but good enough for this purposes. And there's the point 0, 12. I'm going to connect those 2 points, and again, if that bugs you, not spacing the gaps on my axes differently, then just give yourself some more room to do it. That's a reasonable graph. It's not maybe the ultimate best graph, but it's definitely good enough. And this function, because as I'm moving from left to right, it's going down, we say it's always decreasing. So lines will never be a combination of increasing and decreasing. They'll be one or the other, but never some combination of both. All right, so there's the first batch of problems. They all have the same kind of feel. The middle batch of problems have a different kind of feel, and they have a bunch of parts as well. And I ask you to graph. Too bad. So each of the questions, each of the parts requires me to do a bit of algebra, and none of the algebra is that hard. But understanding by reading an instruction what each part wants you to do, that's not something that all of you could do. So if I just handed this problem out to most of you, some of you would know what to do just by reading the problems, but a lot of you wouldn't, and that's okay. So I need to hopefully make it so you understand what each part is asking me to do. Question A that says find out where f of x equals to 0. What we need to do is set the right side. I'll be lazy here, of the f function instead of this, of the f function equal to 0 and solve for x. So I'm going to do this. I'm just going to go negative 3x minus 2 equal to 0. I'm going to add 2 and divide by negative 3. There's no square, so I'm not worried about factoring when I'm doing this. So when I added 2, I got negative 3x equal to positive 2. Now I'm dividing by 3, negative 3. On the left side, I get x. On the right side, I get a fraction that has a positive over a negative. Although it wouldn't be wrong to say x equals to 2 over negative 3, I'm going to drag that negative up to the numerator. That's a more common place to leave the negative. When you just have an integer over an integer, the negative sign can be moved around. So the answer to part A is just x equal to negative 2/3. 12b, find out where f of x is greater than 0. That I'm going to do by just setting the right side of x, the right side of the f function, greater than 0. So basically, any place I see an f of x or a g of x in these instructions, I'm going to place the right-hand side of the function. So instead of writing f of x, I'm going to replace the f of x with negative 3x minus 2. So I'm going to go negative 3x minus 2 is greater than 0. And the algebra is almost going to be identical to part A, but when you're dealing with inequalities, if you have to divide by a negative or multiply by a negative to solve for the variable, you switch the direction of the inequality. So the first step in part A and part B are the same. The second step is the same, except because I'm dividing by a negative 3, I have to switch the direction of the greater than and make it a less than. So the answer to part B is going to be x is less than negative 2/3, and not x is greater than negative 2/3. For part C, it essentially just wants me to set the right-hand side of the f function equal to the right-hand side of the g function. So that's what I'm going to do. So for part C, it says where does f of x equal g of x? F of x can be replaced with negative 3x minus 2. G of x can be replaced with negative 2x plus 8. And if I attempt to solve this for x, I'm going to add 2x to both sides. This will give me negative x, or negative 1x minus 2 equals to 8. Now I'm going to add 2 to both sides. This is going to give me negative 1x equals to 10. And now I'm going to divide both sides by a negative 1. And I get x equal to negative 10. So my answer for where f of x equals to g of x, it's when x is negative 10. Part D is going to look almost exactly the same. The beginning problem, instead of writing an equal between the f and the g function, I'm going to write a less than. So I'm going to write the right side of the f function is less than the right side of the g function. I'm going to do the exact same steps to solve it, meaning first I'm going to add 2x. In fact, let me do two things at once. I'm going to add 2x and 2 on the first step. And when I do that, adding 2x to the left side gives me a negative 1x. Adding 2 to the left side cancels out the 2. On the right side, adding 2x cancels out the 2x, and adding 2 gives me a 10. Just like in the part B, when you divide by a negative to solve for an inequality, you have to switch the direction of the inequality sign. And the answer to part D is going to be x is greater than negative 10. Okay, so that's a chunk of everything, but not everything. Last thing I'm going to need to do is, this is 12C, 12D, is graph f of x and g of x on the same graph and label the solution to f of x equals g of x. Let me show you on my calculator how to do this, and then I'll show you to do it by hand. So I kind of have most of what I need. So let me hit my y equals button. The first y1, I'm going to type the f of x function using the negative in the bottom row of my calculator, and then the negative above the plus sign. Oh, I don't know what I just did. Really? Oh. Y equals negative 3x minus 2. So the f function needed both negatives. The negative in front of the 3 is the one in the bottom row of the calculator. The negative next to the 2 is the one below the time sign. For the g of x, I'm using the negative in the bottom row of the calculator, then the 2, and then plus 8. I know that the x coordinate of where these two graphs are going to cross is negative 10. And I can tell you the y coordinate real quickly. So when I'm going to label where these points, where these graphs cross, and where these graphs cross, the x coordinate is going to be negative 10, because that's what I got when I set f of x equal to g of x. To get the y coordinate of where they cross, I can plug negative 10 into this function, or I can plug it into this function. Regardless of the function you plug it into, you're going to get 28 for the y coordinate of where the graphs cross. So before I jump in and hit my graph button, I'm going to tweak the window so that I can see this point of intersection, because I'm supposed to label the point of intersection, and I have to know where it is, and I knew the x coordinate of where it is because I solved f of x equal to g of x. You can get the y coordinate by taking the x coordinate of where they intersect and plug it into either function. So now I'm going to hit my window button. I need my x's to clearly show the point of intersection, which is at negative 10, my x-min has to be left of negative 10. I'm going to make my x-min negative 15. If you like symmetry and you change the x-max to 15, there isn't anything wrong with that. If you left the x-max at 10, there isn't anything wrong. There isn't a one right window, but there are windows that might not show the point of intersection. So the x-min has to gobble up this negative 10. Similarly, the y-max needs to be able to show the 28. So this y-max at 10 isn't going to be high enough. If I make the y-max at 30, the 28 would be right at the top of the screen. I'm going to make my y-max at 40 just so I can clearly see the point of intersection. It isn't just buried at the top of the screen. And then my y-min is at negative 15. If you want to change that to negative 40 because you like the symmetry, that's fine. So let me do that just in case you need to see that symmetry. If you have a different y-min than me, then the slopes of the line might look different, but the intersection point's going to be the same. So when I hit my graph button now, first line it's drawing is the F line, second line it's drawing is the G line, and the point of intersection, which is negative 10, 28, is there. Can use my calculator to find that point to make sure I haven't messed up on that point, negative 10, 28. To get your calculator to find the intersection point, if you can see the intersection point graphed and you want to find it, you hit the second button and then the trace key. So I'm going to hit second and trace key. Go down to number 5 that says intersect. I think if I close my eyes and hit enter 3 times, that it'll give me the correct intersect, but hitting enter just once isn't good. There's things that I can do that the programmers of the calculator wanted me to do, but just hitting enter once, enter twice, and enter 3 times isn't enough. Too bad. I thought I could, but I'm too far away from the intersection. So I have to go, let me do this again. I go second, trace, go down to number 5 that says intersect, and then use my cursor and trace as close as I can to where the graphs intersect, and then hit enter 3 times and you'll be okay. I thought I could get away from that tracing to close to where they intersect and then hitting enter 1 time, 2 times, 3 times. And it magically tells me they intersect at the point negative 10, 28. Sometimes it doesn't do perfect algebra and it gives the x coordinate that needs to be rounded. It could have given me like negative 9.9999928. It always gives the right y coordinate, but sometimes the x coordinate needs to be rounded. So I haven't finished this yet because I haven't done the graph. But let me actually do the graph that's asked for in part E, and I'm going to really force this graph to be more accurate than I might normally by drawing the point of intersection first. So I need to draw that point negative 10, 28, 3, 2, 4, 5, 6, 7, 8, 9, 10, and then, so this is negative 10. And I need something to represent 28. So, oh gosh, I'm going to go by 4s. 4, 8, 12, 16, 20, 24, and 28. So here's the point negative 10, 28 where the 2 graphs intersect. I can actually write that. Let me finish up the graphs. For the f graph, f of x equals negative 3x minus 2. To finish up that graph, I'm going to plot the y-intercept, which is negative 2. And now I'm going to connect these 2 points. This is the f graph, drawn reasonably well. So this is the f of x equals minus 3x minus 2. I did a cheat graph. I plotted the point of intersection, plotted the y-intercept, and connected them. I'll do something similar for the g graph. The g of x, I'm going to graph in a different color just so you can see it, as negative 2x plus 8. I know the y-intercept is at 8. I also know it goes to that point, and so let me connect the point of intersection with the intercept, and that would be a decent graph. If you compare that graph to my calculator's graph, you know, they're pretty darn similar. For my perspective, that's as good as I can do, especially without having graph paper. So that's 12E, done, as nice as you might ever like to see it done, hopefully. All right, so now let me move on to 14, which I imagine is a similar problem. 14 again asks the exact same questions for a new set of functions. So the first part of 14, part A, wants me to find where f of x is equal to 0. So to do part A, where f of x is equal to 0, I take the right-hand side of the x function, which is 3x minus 6, set it equal to 0. There's no square, so I don't need to factor. I'm going to add 6 to both sides and get 3x equals to 6, and then divide both sides by 3 and get x equal to 2. To save room, I'm just going to write the answer up here. To do part B, to find out where f of x is greater than 0, I take the right side of the f function, which is 3x minus 6, set it greater than 0, do the exact same algebra, and in this problem I'm not going to need to make the greater than into a less than, because I'm not dividing by a negative. So when I take the time to solve this inequality, I'm not flipping the inequality. You only flip the inequality if you have to multiply or divide by a negative. And the number that I divided by was a positive 3, which doesn't force me to flip. C wants me to find where f of x equals g of x. I do that by setting the right-hand side of the f function, 3x minus 6, equal to the right-hand side of the g function, 4x plus 4. I'm going to be slick. I'm going to minus 3x and minus 4 from both sides, just because I can tell that was going to make my x positive. If I minus 4x, I was going to get a minus x, and I'd have to do an extra step. So minusing 3x cancels the x's from the left side. On the left side, the 6 and the 4 have the same sign, so I add those and keep them negative. On the right side, 4x minus 3x is 1x, and the 4's cancel. So again, I get x equal to negative 10 for the answer to part C. For part D, finding out where f of x is less than g of x. I like having the x on the left side when I have an inequality, although there's no reason it has to be that way. When I solve this, I won't be as slick as I was for the last one. Just because when I have an inequality, I prefer having the letter on the left side, even though it's not absolutely required. It just is common. So when I'm solving this inequality, f of x is less than g of x. Oh, I messed up. I'm supposed to minus 4x on both sides. So I'm going to go minus 4x and plus 6 to both sides. On the left side, if I go minus 4x, 3x minus 4x is a negative 1x. If I add 6, the 6's will cancel. I'm not multiplying or dividing by a negative. I'm adding and subtracting, and that doesn't change the direction of a sign. Here I made the 4x's cancel, and the 4 and the 6 are 10. Now I'm going to do my division. I'm dividing by a negative, and if you divide by a negative, you switch the direction of the inequality. On the left-hand side, I get a positive x. The less than switches to greater than because I divided by a negative. 10 divided by negative 1 is negative 10. When I go to sketch my graph, I'm going to make the window work well. I know the x-coordinate of where the graphs are going to cross is at negative 10. To get the y-coordinate, I could take this negative 10, plug it into the f function, or I can plug it into the g function. They both are okay. If I plugged it into the f function, I'd go negative 30 minus 6 and get negative 36. If I went to the g function, I'd get negative 40 plus 4, which is negative 36. So these two graphs are going to intersect at the point negative 10, negative 36. When I go to sketch my graph, if I'm going to use my calculator, I'm going to make sure to show that in my window. When I go to do it by hand, I'm going to do the cheat graph. I'm going to plot the point of intersection, the y-intercepts, and make my graphs. So when I'm going to graph the f of x equals 3x minus 6, I'm going to plot the point -10 comma -36 because that's where the graphs are going to intersect. And also, I'm going to plot -6 on the y-axis. And then I'm going to connect those. When I go to do the g of x equal to 4x plus 4, I'm going to also plot the point -10, -36 because those are where the two graphs intersect. And I'm also going to plot 4 on the y-axis because that's the y-intercept. And I'm going to connect those points. So let me just throw those, do that graph quickly. So a -6, so oh gosh, I can do these by 1. I've got to get down to 36, so I'm going to go by 6. So I'm going to go -6, -12, -18, -24, -30, and -36. And then on the x-axis, I don't know, if I did by 6s again, just to be, there's 6, there's 12. So this is about 10. So if I, for the y, I plot -6, oops, for the f, I plot -6 on the y-axis. There's the point 0, -6. And then I plot the point -10, -36. And I connect those points more or less with a straight line, arrows signifying the graph doesn't stop. For the g function, if I call that 6, I'm plotting 4 on the y-axis, which is about there, and that point -10, -36, and then trying to connect those. My graph isn't perfect, but it's good enough. It's supposed to actually go right through that point, and I'll do this on my calculator so you can see better how the graph should look, but that I can't, that's good enough. And even though it's not really, this purple graph should be down there more, but this is the graph that you should have. How about this? Hit my y equals button. Y equals clear, clear, then 3x minus 6 and 4x plus 4. So those are the two functions. I need my window to show my x's are going up to cover up -15 is far enough because I just need to make it to -10. My y's only need to get down to -36, making my y go to -40. I'll barely see the intersection. I'm going to make my y min go to -50. I'm not even going to take the time to change my y max. And when I hit enter, there's the f function, there's the g function, kind of like I have drawn. I'll show you that this point is the right point by going second, calc, going down to option 5 that says intersect, and then I trace, and I get as close as I can to the intersection point, which isn't too terribly close. Close my eyes, hit enter 1 time, 2 times, 3 times, and it tells me that they intersect at the point -10, -36, and I did exactly what I was set out to do. So this is part, I think this was E of number, what question it was, question 14E. It's the graph that was asked for.